All right, we're going back to school stuff. I'm gonna be honest. I kind of forgot that we had school this morning. my, I woke up this morning and my husband was taking a shower, and I was so confused why he was in the shower so early. And I was like, "Why is he taking a shower?" And then, like, I went back to sleep, and I woke up to him shaking. He's like, "I'm going to school," and I'm like, "Why are you going to school?" And I literally rolled around. I like yelled at him. I was like, "Go away!" I like went back to sleep. And I woke up like I have an 8 a.m. class, so I woke up at like 7:35 and I was like, oh, I got school today. So I had to like rush to school. But yeah, that happened this morning. So I have been making some random mistakes during class and just bear with me if I say something weird. I don't think I'm gonna say anything weird today, but just bear with me here. All right. So what we're going to do is talk about this thing called hypothesis testing. This is a brand new topic and kind of like confidence intervals. It's not something you hear every day. Like you hear mean, median, and mode and pie charts and things like that all the time. But the idea of hypothesis testing isn't something that kind of gets thrown around a lot. So to kind of help you out with this, I'm going to do an experiment, and that's going to give us like some baseline of what we're doing, and it's going to give us some intuition on what exactly hypothesis testing really is. Okay, so what we're going to do is I actually have a deck of 52 cards with me. Okay, it's a standard deck, and in standard decks, the deck is kind of split. So in a standard deck of cards, we usually have half red cards and half black cards. Okay, so there's 26 red cards, 26 black cards. And what we're going to do is we're going to select 10 different cards. Okay, it's going to be at random. And out of 10 cards, we're going to count how many red cards that there are. Okay. Now, before we do any experiment, we always say a hypothesis. Does anyone know what a hypothesis is?
I guess.
It's a guess, right? I think the phrase educated guess gets thrown around a lot. So whenever you do an experiment, it's the hypothesis is what you think is going to happen. Okay, so that's our educated guess. Okay, so what we're trying to guess is whenever you shuffle a deck and pick 10 cards, what do you think like the mean number of red cards that there are? Okay, so I'm going to say the mean number of red cards. Remember, another way to say mean of in general is mu, right? Well, if I pick 10 cards, how many do you think are going to be red?
5.
5, right? Because there's half red cards, half black cards, right? All right, well, why don't we do the experiment and see what happens? All right, so I got my deck. It's already shuffled, so I got this, and I'm going to have us pick some cards. So how about Brittany? Do you want to pick the first one? All right. All right, is it black or red? Black. All right, it's a black card. I'm going to put it back in the deck at random, and we're going to tally up black. Okay. Don't have to shuffle too well because I'm only putting one card back. All right. What's next? Looks like it's a black card. Good. All right. Back at random. And we'll make a tally mark here. All right, gonna shuffle it a little bit, but we don't need to shuffle it too much. Okay. How about Ariel? Looks like we got a black card. Uh-oh. All right, we got 3 in a row. That's kind of weird. All right, let me shuffle it a little bit better this time. Too much. All right, let's do Claire. You want to pick one? Sure. This one. Yep, it's another black card. No way. It's kind of weird. Oh gosh, it's because I woke up too late. That's what happens.
No.
No, it's because I woke up too late. What are you talking about? All right, let's do Jade.
I think you need to prove that there's a red card in there.
Oh. Interesting, interesting thought there. All right, we got 5 in a row. Oh my goodness. But you were so confident in the beginning. All right. Let's do. Another black one. Uh-oh. Got another black card. All right. Yeah, we shuffle it real good this time. Uh-oh. Oh no, my card's flipped over.
What if there's just no red cards in there?
Oh my goodness. Oh, we got another black card. Uh-oh. Oh my goodness, we got 7 in a row. Okay, I get some red cards in here. I think maybe people in the back might be. Oh, we got a black card. Oh, we got 8 in a row. What in the world is going on here? All right, we got 2 more. This is our last chance, guys. All right, I'm counting on you. Ruining my experiment. Yeah, what's Savannah? Here we go. That's a joker.
That's why I was the Joker was some of that.
Oh, we got another black card. Uh-oh. All right, I think the last one. Yeah. Oh gosh, another black card. We got 10 black cards in a row. I don't even know how that would happen. Oh my goodness. 10 black cards and 0 red cards. Okay, so let's just think about what we did. We made a hypothesis. We talked about what we thought was going to happen. We said the mean number of red cards is going to be 5. Then we did a tally, and our evidence says that maybe the mean number of red cards isn't actually equal to 5 based on our information here, right? All right, let's answer some questions here. Do you think this deck has a 50% chance of drawing a black card?
Yes. Maybe higher than that. Yeah, maybe 100% chance.
Yeah, maybe it's 100% chance, right? That sounds a little bit better. Yeah, I don't think there's a 50% chance of drawing a black card with my deck here. Let's talk about a normal deck. Okay, so let's say a standard deck that has 50% red cards, 50% black cards. Is it possible that someone could pull out 10 black cards in a row with a standard deck? Yeah, that's a thing that can happen, right? So what I did here, that's not impossible. I didn't do something crazy. This can happen. But is it likely to happen? No, right? It almost never happens. To the point where, like, when it happens, it's like, what in the world is going on? This deck is not right, right? All right. So there's something going on here, right? We have 2 contradictory pieces of information. Our claim or our hypothesis said that the mean number of red cards, so the mean number of red cards was equal to 5 out of 10, right? But what happened was there were 0 red cards. Oh my goodness, 0 red cards. Okay, so what can our conclusion be?
Picking a black card is one of them.
Yeah, right. It actually seems like the mean number or the population mean of picking or how many red cards there are in this deck, it's not equal to 5, right? Our hypothesis is not true, right? So we essentially rejected our hypothesis in the beginning, okay? Now, let me ask you a question. Okay, I'm gonna set up a chart here of red versus black cards. Now, in our situation, we had 0 red cards and 10 black cards, and we were like, yes, our hypothesis is not true. Okay. What happened if I got 9 black cards and 1 red card? Would you still say my hypothesis is not true? Yeah, right. That would be pretty confident. I'd be like, okay, maybe there's some red cards in this deck, but definitely not 50-50. Okay. What if I had 8 black cards and 2 red cards? Yeah, that's still not really probable, right? What about 7 black cards and 3 red cards? Yeah, but it could happen, right? I could get 3 red cards and 7 black cards. That seems kind of possible, right? And then 4 red cards and 6 black cards, that's definitely a thing that can happen. That's something that we would expect to happen. So the idea of hypothesis testing is figuring out where the line is. Is it here? Is it here? As to where we reject our hypothesis or where we say our hypothesis is still true, okay? So we're trying to figure out where, what proportion of red versus black cards can we say that, okay, this deck is definitely not 100 or 50-50 black and 50-50 red. Okay, now I'll tell you what actually happens. There were actually all black cards in my deck. So
Say what?
what? Oh my goodness, I tricked you. How dare I lie to my students? But this is kind of my idea of hypothesis testing. It's something that we should keep in mind because I think it kind of helps us understand this topic a little bit better with an example. Okay, so here's the idea of hypothesis testing. We set up a hypothesis and we assume that it's true. So in the beginning, we said that the mean was 5 and we were pretty much confident that the mean was going to be 5, right? It's going to be around 5. Then we're going to gather some data from the real world, like picking cards, and we're going to process that data and see what happens. And then finally, we're going to figure out, okay, is my hypothesis likely? Is it not likely? And we're going to see if we say our hypothesis is not true, or we're going to say if our hypothesis is true. Okay, so we're going to figure out which one that we can say. Okay, now something I didn't tell you is we made one hypothesis in our example. There's actually technically 2 hypotheses that is going on. One is our hypothesis that we believe is true, and the other one is kind of the other thing that can happen, okay? We call this the null hypothesis and the alternate hypothesis. And to kind of help us understand this, I'm gonna talk about what these mean in the abstract, and if this doesn't make any sense, I promise you it'll make more sense in the examples, okay? So just bear with me while we do this chart, and then we'll talk about the examples later. Okay, so the null hypothesis is what we believe in the beginning, like the mean is 5, and we have a symbol for it. It actually takes on this symbol, H for hypothesis, and null means nothing or like nothing at all, or 0. So we're gonna put a 0 for null. Okay, so H subscript 0 is the null hypothesis, okay? And when we talk about the null hypothesis, we kind of have to write it in the right way, kind of like how we did with the confidence intervals. Whenever we talk about the null hypothesis, we're going to use the symbol. Okay, so the null hypothesis, we're going to put a colon after it to say, this is what the null hypothesis says, okay? In this class, we're always going to talk about the population mean. Okay, so we're always going to talk about mu, okay? And the null hypothesis always says that the mean is equal to something. In our example, it was 5. Okay, so the null hypothesis always looks like this. It says, here's my null hypothesis, the mean is equal to a number. Okay. Now, the alternate hypothesis is something else that can happen, okay? The symbol is H for hypothesis, but since it's the other thing than 0, it's H1, okay? And this is going to tell us the other thing that can happen, okay? Basically, it takes on the same shape as the null hypothesis, so H1 colon, still talking about the mean, but instead of an equal sign, it's either going to be a less than, greater than, or not equal to sign, okay? Now, if that made no sense, let's do an example and try to see how this evolves when we do a question. All right, so we have boxes of a certain type of cereal. They're labeled as to containing 20 ounces, so we're pretty sure that they're about 20 ounces. An inspector comes in and thinks that the mean weight may be actually less than this, okay? We want to figure out what the null and alternate hypotheses are. To do this, I'm going to do the null hypothesis first because that one's kind of easier. I'm going to take my null hypothesis symbol, put a colon after it, and we're always talking about the population mean. Okay. We just kind of start out like this. The null hypothesis always has an equal sign, okay? And we're saying that what we think right now is that the mean is equal to something. What number do you think the mean is equal to here? 20, right? That's what we go in thinking. Boxes are 20 ounces. All right, I believe that. Let's just say we believe that the mean is equal to 20. Okay. The alternate hypothesis is the other thing that can happen. Okay, so alternate hypothesis is H1. We're still talking about the population mean, and actually everything's pretty much the same, including the number. Okay, so the number for the null and alternate hypothesis are always the same. The only difference is the symbol. Okay, now do you think it's going to be greater than, less than, or not equal to here? Less than, right? Because it says the inspector thinks the mean weight may be less than this. So based on that, I'm going to use a less than sign, and well, that's my null and alternate hypothesis. Any question on this example?
So now I should start.
Yeah, we're not solving anything. We're just, this is kind of like how we write our answers. We're just practicing how we like write the hypotheses. We'll talk about the conclusion next, but no solving. Yeah. All right, why don't you try example 2? And if you flip over to example 3, there's also one. So try 2 and 3 and we'll come. All right, let's come up to the front. I think all your answers were looking really good, but just to go over stuff, I'm not going to ask McKenna or Savannah to kind of go through this because I think we're all on the same page here. But let's see, McKenna did a great job of doing the null and alternate hypotheses here, using the correct symbols, and we did greater than because, well, we thought it was higher, right? Any questions on number 2? All right, moving on to example number 3. You want to do scores on a standardized test. We said it had a mean of 70, but we think it might have changed. This time Savannah did a good job of writing out the null and alternate hypotheses, but this time the symbol is not equal to because, well, it doesn't say higher, lower, less than, greater than, nothing like that. So that's a good sign that we have to use the not equal to sign. All right. Any questions on writing out the hypotheses? All righty. If we go down, I have a bunch of stuff about hypothesis testing, and I guess I'll talk about it a little bit. Whenever we do a hypothesis test, we first assume that the null hypothesis is true. Kind of like in our example, we said that, gosh, the mean was equal to 5, right? The amount of, we thought that the amount of red cards was going to be equal to 5, okay? Then we look at the evidence. We had 10 black cards and 0 red cards. And that kind of gave us an idea of, well, how plausible is our null hypothesis, okay? Now, whenever we do hypothesis testing, there's only 2 options that we can do at the end, okay? So there's 2 conclusions. We can either reject the null hypothesis, so say that HO is not true, or we can fail to reject the null hypothesis. So we can say, oh, looks like HO isn't true, kind of like how we did in our example, okay? Now, when we write our conclusion, we have to use the right phrasing, which is kind of very similar to confidence intervals, but the way that you go about it is a little bit different. So let's talk about what happens when we either reject or fail to reject the null hypothesis here. So what we're going to do is we're going to go through a few examples, and we're going to write out how we say our conclusion, okay? So example 1 is our cereal example with the 20-ounce cereal. In the last example, we found the null and alternate hypotheses. And it looks like this person rejected the null hypothesis. So he did a bunch of work and he said, I don't think the null hypothesis is true, okay? We're going to talk about how we're going to write this conclusion, and we have to use the right phrasing, okay? So when we write out this conclusion, I like to think of it as piecing together 2 parts of a sentence. Okay, so there's 2 parts of the sentence. There's going to be one part and then there's going to be another part. Okay, the part at the end is always going to be the alternate hypothesis or H1. Okay. Okay, so the alternate hypothesis always goes at the end of the sentence. So in this case, I'm going to take H1, mu is less than 20, and I'm just going to stick it at the end of the sentence. And that's it. Okay. Now, for the beginning of the sentence, we're going to look to see if we reject or fail to reject the null hypothesis. If we reject the null hypothesis, we're going to start our sentence with this. We conclude. And the reason we do this is if we're rejecting the null hypothesis, we're basically accepting the alternate hypothesis, right? So we're basically saying, okay, it's not HO, so it has to be H1. Okay. Whenever you write your conclusion and you reject the null hypothesis, this is how you're going to write your answer. Okay. Any questions on example 1? All right, let's talk about how we write if we fail to reject the null hypothesis, right? What we're going to do is we're going to skip example 2 and go down to example 3. Okay. Example 3 is the cereal box sort of situation. Still have the same null and alternate hypothesis. In this case, we still are piecing together 2 pieces of a sentence. Okay. The end is always the alternate hypothesis, so it's always the same. Okay. The alternate hypothesis, mu is less than 20, always goes at the end of the sentence. Okay. Now, the beginning of the sentence does change because we don't reject the null hypothesis. We're actually not rejecting the null hypothesis. Okay, so when we either fail or don't reject the null hypothesis, this is what we're going to say. There is not enough evidence to conclude. Okay, so when we don't reject or fail to reject the null hypothesis, we're always going to say this, because if we don't, then we kind of risk communicating the wrong thing. Okay, we can't just accept the null hypothesis. We kind of have to always talk about the conclusion in terms of the alternate hypothesis, and either say that we're accepting it or there's not enough evidence to conclude that it's true. Okay. Any questions on writing out the conclusion? All right, then why don't you try example 2 and 4? Okay. Very similar, just piece together the 2 parts of the sentence. Second part of the sentence always stays the same. First part kind of depends on the question. Here, so very good job as I've been walking around. I think everyone was pretty good with writing out these conclusions. I'm not going to ask Ashley or Katie to explain it because I think it's kind of self-explanatory. In example 2, we had the restaurant owner and he rejected the null hypothesis. So we kind of pieced together, we conclude because we rejected, and then the null hypothesis at the end, or the alternate hypothesis at the end. And then example 4, Katie did a good job of writing out the beginning because we did not reject the null hypothesis, and then we ended out the alternate hypothesis at the end. All right. Any questions on writing our conclusions? All right, then we have done the hardest part of hypothesis testing. I promise writing out the null and alternate hypotheses and writing the conclusion, those 2 are kind of like the hardest things of hypothesis testing. The rest is not that bad. So let's just talk about one last thing here. Okay? So one thing we haven't talked about that much in statistics is the possibility of saying the wrong thing, making an error. And statistics is kind of different than other branches of math. In algebra or calculus, usually you get an answer and you know that's kind of like the right answer, right? In statistics is a little bit different because you're getting examples from the real world. It's kind of more subjective, and sometimes your answer just isn't the right answer in terms of reality, right? Let's say that we concluded after getting 10 black cards in a row that the deck wasn't 50-50, and I turned around my deck and it actually was a 50-50 deck, right? Well, we made a conclusion based on our evidence, and it seemed like a good conclusion, but we made the wrong decision. That's an example of making an error, okay? So we can say a conclusion, but in reality, it's not being true. That's an error, and there's actually 2 types, okay? And a way to kind of talk about these types of errors is through this chart, Okay. Now, if this doesn't make too much sense, then I promise you, when we do an example, it'll make a lot more sense. But let's say we've rejected the null hypothesis, like as our conclusion, okay? Now, in reality, the null hypothesis could either be true or false. If it's false and we rejected it, then it looks like we did make a correct decision because we rejected something that wasn't true. But if we reject something that is true, we're going to call that a type 1 error, okay? Now, if we fail to reject something that's true, that's a correct decision. But if we fail to reject something that's false, we're going to call that a type 2 error, okay? Now, some things about this class, I will always give you this chart on a test or quiz. What I want you to do is be able to interpret a word problem and use this chart for it. So make a note that you don't have to memorize it, okay? So don't memorize this chart. Okay, but you do, or you should be able to use this chart on a test or quiz. Okay. So if that didn't make any sort of sense, let's do an example and I promise you I'll make a little bit more, it'll start to click a little bit better. Okay. Let's say you're a dean of a business school and you want to figure out, okay, is the mean starting salary of graduates of your school greater than 50,000? Okay. So what this dean did is she did a hypothesis test, wrote out her null and alternate hypotheses here. And now we have more information. It says, suppose that the actual mean, and what this means is the mean in real life, is equal to 50,000, okay? Let's figure out what that means. If the mean is actually equal to 50,000, is the null hypothesis H0, is that gonna be true or false? It's gonna be true, and why is it true? Yeah, right. It says what actually happens is, well, it literally matches the null hypothesis, right? Because they're the same, the null hypothesis is true. Okay, so that is true. Okay, it says that the dean rejected the null hypothesis. So the dean rejected HO. Okay, so what this is saying is on the bottom here, we have the conclusion of our hypothesis test. That's what the dean said was true. But up top, we have what's actually true in reality. Okay, so what's actually going on in real life. What we're going to do is we're going to go to our chart. We rejected HO, so we're using that top column or top row. HO is true, so we're using the first column. Did I make an error? And if so, what type? Type 1, right? I'm using the first row and the first column. So this is a type 1 error. Okay. Does that kind of make sense? All right. How confident do you feel doing example 2 and 3? All right. I'll have you try it and then we'll go over it together. How about that? Do this in front of the class here. We'll do a lot more practice together next class, but let's just go through example 2 real quick. We said that the actual mean was equal to 50,000. So does that mean HO is true or false? True, right? Because it's equal to and matches the null hypothesis. So HO is definitely true. Okay. And then it says fail to reject, right? So fail to reject. So what you'll do is you'll go into your chart. You'll look at HO being true. You'll look at fail to reject. Did I make the correct decision? Yeah, right. I made a correct decision here. Okay, so this one was a correct decision. Oh my gosh. All right. Example 3, it says that suppose the actual mean is actually greater than 50,000. Is HO true or false this time? Good. So basically, rule of thumb, if it's equal to, HO is true. If it's anything other than that, it's got to be false, right? Okay, it says does not reject, so fail, right? Okay, so taking a look at my chart, we got a false, we got a fail to reject. What type of error did I make here? Type 2 error, good. All right, any questions on these examples here? Okay, now, not so much last semester, but my first semester when I taught this, a lot of students got this sort of question wrong on their test. So what we're gonna do a lot more practice with using this chart next class. And yeah, I guess I'll see you on Wednesday.